Okay, so our last section in this chapter talks about factors affecting enzyme activity. So how can you change how an enzyme functions? So activity, in terms of enzyme activity, we need to define that. And activity is defined as how fast an enzyme operates. So a reaction rate is a measure of enzyme activity. So there are three things that can affect enzyme activity. We'll talk about two in this video and then one in our next video. But the three things are temperature, pH, and inhibitors. So let's go to temperature first. So this chart here shows temperature on the bottom here, and then rate on the y-axis. So as you can see, for this particular enzyme that we are looking at, as temperature increases, the rate increases. You're adding more energy to the system, therefore it can move faster, has more giddy up to the system pretty much. Then you have an optimum temperature where you have a maximum enzyme activity, but then as you go higher than that, you see a significant drop off. And that's because you're denaturing the protein. You're changing how that protein folds. So you're changing those hydrogen bonding interactions. So let's look at this in words. So we saw a picture form. Let's look at the word form. So at low temperatures, there's low activity because there's not enough energy to give it enough oomph to go. At high temperatures, you have too many or more collisions, more activity happening, more molecules bumping into the enzyme. Therefore, you have a higher activity. But if the temperature goes too high, you denature the protein, denature the enzyme, and cause the reactivity to go away. So typically in humans, the optimum temperature for our enzymes is about 37 degrees. Nature made us that way because that is our natural body temperature. However, thermophiles, so these are animals that have typically have body temperatures around 50 to 120 degrees Celsius. So they like living in hot environments. They have enzymes that are special to have optimum temperatures at higher temperatures. They typically will have more hydrogen bonding and salt bridges associated with those enzymes to keep their structure at those higher temperatures. So first off, temperature affects how fast an enzyme operates. And then additionally, pH, so how acidic or basic the solution is. So again, you see let's orient ourselves to this graph. We have pH on the bottom, so we have more acidic on this side with a low pH, and basic on the right side, the higher pH. And then again, the y-axis is reaction rate. So there's an optimum pH for every enzyme where the activity is greatest. So that's what our first bullet point says. So there's an optimum point at the very top where there's the most activity from this enzyme. When you change the pH, you change the charges on the amino acids. So if you make it more acidic, maybe you're protonating a lot of different places on the amino acids on that protein. And so it can overall change the structure. So if you change the pH a lot, you're going to disrupt those tertiary or even the secondary too structure, making it so those H bonding interactions can't occur or the salt bridges can't occur or something like that. So if you have a drastic pH change, so if there's a big pH swing, then you denature the protein. So you're fully disrupting those correct folds. If you just vary it slightly, you lose some activity, but it doesn't completely kill it. I don't know why this made me think of it, but part of alcohol poisoning changes the pH in your body. So you have to be really careful because if you start changing the pH of your blood, you start denaturing your hemoglobin, making it so that your blood can't carry oxygen anymore. So when they there's alcohol poisoning, they'll actually put like a buffer solution into your bloodstream to try and keep and prevent any more hemoglobin from being denatured. Random fun fact. Okay, most enzymes, especially for us, have an optimum pH of 7.4, so right around neutral. However, different places in our body have different acidities. So pepsin, which is a protein in our stomach, likes things that are really acidic. Our stomachs are very acidic. So it will have an optimum pH really, really low. However, opposite is true for our livers, which like a basic environment. So their optimum pH is about 10.